Logarithms. There's the fancy definition. The logarithm of any number to a given base is the index of the power to which the base must be raised in order to equal the given number. Basically it's saying this: if n is equal to a to the power of x, a of course has to be a positive number and not equal to 1, then x is equal to the log of that number, base a. The base doesn't change. They're basically inverses of each other. Okay, so if we have to work out this one, so x is log 1000 base 10. So what we're basically saying is 10 to the power of what is 1000. And you could formalize it by actually doing the inverse operation. And I suppose what we have done is we have exponentialized both sides, if that is a word. X equals 3. Here we got another one. 5 to the power of what is 1 on 25? Well, that's where we use negative indices, isn't it? Negative 2. In this case, it's the base that we want to find. So we're saying x squared is 64. So x is 8, not plus or minus 8. So normally when we see x squared equals 64, we'd say x equals plus or minus 8, but we're looking for the base of a logarithm here, and that's defined to be a positive number. This time we've got x is 6 squared. Well, that's a quick one, 36. We have some rules or laws that allow us to manipulate the logs to make the math easier. So if you have log a to the power of x base a, the answer is going to be x. If you have a to the power of log x base a, the answer is also going to be x. So both of these are basically saying inverses cancel each other out. You've got a log of an exponential in the first one, and the second one you've got an exponential of a log. Log 1 is equal to 0. Well, that basically comes from the index law, a to the power of 0 equals 1, so it's the inverse of that rule. Log a base a is equal to 1 because we know with indices a to the power of 1 is always a. Log x plus log y will be log xy. Well, that comes from the index law that says when you multiply, you add the powers. So in this case, when you add the logs, you multiply. And similarly for division. And this one here is the one that allows us to bring the power to the front of a log. And that comes from the idea that a to the power of px is actually a to the power of x or to the power of p. Now, why do we have these laws? Well, I guess originally the main reason was before the calculators were around. And we had these wonderful things called mathematical tables. And you'd have to look up the table to find the answer, because if you wanted to, well, multiply really big numbers or something like that, it's a lot easier to add than multiply. And so it converted a multiplication into an addition. And you'd use your log tables to do that. So you had log tables, but then you also had anti-log tables. So then once you worked it out, you could go back and get the actual answer. It was great fun. You missed out on it. So using our log laws, because see, log 20 base 10, 10 to the power of what's 20? A bit hard to work that one out. But if we use our log laws, we can combine this and it becomes log 100 base 10, and that one we can work out easily. That's 2. Subtraction, same here. Well, 2 to the power of what's 18? Again, too hard to work out, but combined together, we end up with a simpler one. Log 2 base 2 is 1. Ooh, we got 3 logs here. That's all right. If it's positive, it means multiply. If it's negative, it means divide. Got to be careful with the last one, 2 log 6. So bring the 2 in, it actually becomes 6 squared. So we get the log of 9 times 8 over 6 squared, which is 2. 4 to the power of what is 2? Well, 4 to the power of a half is 2. They've given us the answer to these ones. Now, obviously, they're not exact. I mean, if you did 10 to the power of 0.3010, you're probably not going to get the answer 2. You probably get something very close, though. As I say, it's an approximation. But using that, let's work out what log 27 would be. So how can I get 27 from the numbers that I know? I know 2, I know 3, I suppose I know 10, because log 10 base 10 would be 1. How do I get it? Well, 27 is 3 cubed. So I can say, well, it's 3 times the one you gave me for log 3. Square root of 2. You see, here's a good example. You wanted to find the square root of a number, again, before calculators. Then what you could do is you could say, well, hang on, That's the same as a half log 2. You'd go and look up log 2 in the table, and then you'd get the answer, 0.3010, and then you could convert back, or half of that, sorry, you get 0.1505. Log 12. 12 is 4 times 3, so we can write that as 3 times 2 squared, and then again we can substitute in the numbers we've been given. So let's play with logs.